So why the railway network is interdependent with the electrical network? So it's a very easy to understand because basically we need electricity to drive the railway the cars basically. So if you don't have electricity, then the trains cannot go anywhere. And then of course we also need telecommunication system for the railway because we need to communicate some instructions from the controller to the railway driver. So if you have something happening in front of you, maybe you'd better to slow down, otherwise you're going to crash with someone else, right? And then of course we also have interdependency between the telecommunication and electrical system, simply because we need power to drive the telecommunication system, and at the same time we also need telecommunication system to control the complex electrical network. Yeah.
So those systems, telecommunication power systems, they are not working in an isolated mode. So they are also not settled in a peaceful world, which means they're constantly challenged by a variety of external threats, like extreme weather event, like nature disaster, especially in the context of a global climate change, right? And also they are constantly challenged by all kinds of malicious cyber and physical attacks. So the combination of those threats together are pushing our system towards the brink of a catastrophic failure. So for example, the 2003 Italian power blackout, so it caused millions of people lose their power electricity, and also it has a very big impact on the other sectors like telecommunication, railway, transportation. So those sectors are all highly impacted by the blackout event.
During crisis management, decision makers have many levers or resilience strategies that they can implement. So nowadays, they are trying to do the best they can, but they don't have the tools in order to get the optimal combination of all the different strategies they have at hand. So our work tries to help these decision makers to choose the best options.
So let's say prediction of this kind of failure is not a very easy task, of course. So that's why we are doing a lot of research about this topic. So in general, our research focuses on, so first of all, is how to model the this kind of highly interconnected complex system. So the interconnected railway network, electrical network, and telecommunication network. And then we are making use of this kind of model so that we can try to simulate, under what kind of scenario we might have troubles.
Which component of the power network will supply the electricity to specific components of the railway network has a huge impact on the resilience of interdependent railway power networks, on their combined resilience. And my work is to optimize this coupling topology and to find what is the best coupling strategy using optimization techniques for optimizing the combined resilience of interdependent railway and power networks. In the existing literature, academic research literature, most of the coupling strategies between interdependent networks and interdependent infrastructures are based on network science and network metrics. These strategies are heuristics. They do not guarantee a global optimal solution, while our approach, under some mild assumption, guarantees an optimal solution. And it outperforms the network metrics-based coupling strategies.
So a resilient railway system or a resilient electric system are really based on a resilient telecommunication system. Why? Because all the systems, they communicate with one another, and they really depend on a resilient telecommunication system. Lots of industries, they try to make their equipment more intelligent. A solution for that is to adopt a 5G system. So 5G system becomes an enabler for this kind of smart industry. So my work is to model a 5G system and try to verify if 5G is enough or with certain configuration is able to satisfy the requirements from the vertical industries.
So the three networks are complex for different reasons, and my focus in my PhD thesis is to address the complexity of specific fleet systems, what we call also distributed systems. Concretely, it will be the study of fleets of trains, of wind turbines, or data centers, for example. In my thesis, I try to address the complexity of maintenance strategies. Because they are networks and they must ensure a certain level of service with some safety constraints, we must design maintenance strategies at the system level. And designing such maintenance strategies is a complexity in a sense. To give you some examples, we have some opportunistic maintenance strategies that when we want to maintain a certain part of the network, it's more interesting to consider some geographically related parts of the networks. Or also to make sure that when we have 1 or 2 trains failed, it's not too bad, but we don't want to have 20 trains failing at the same time. So that's why we need to consider the system as a whole, and the maintenance strategy is critical to ensure this specific level of service at the cheapest cost.
Our team is working in the RAMS field, meaning that we are looking at the reliability, availability, maintenance and safety of industrial systems and critical infrastructures. In this video, we chose to focus on a very big project we have with 3 main industry partners: the French main electricity provider, the main French telecom provider, and the main French railway company. And the idea is to look at the availability and the safety and the maintenance of these 3 companies, which are interconnected in 3 interdependent networks. And as a whole, we will assess the maintenance and the resilience of these 3 interconnected networks.
So the atmosphere in our team is highly, I would say everyone enjoyed doing research and in general living with our colleagues in this environment. And then we actually work quite hard, but at the same time, we also have a lot of activity which is devoted to entertainment. For example, we have hiking together.
So during my research, I have the opportunity to participate in lots of conferences, and it's also a moment that everyone in the team, we submit a paper and we participate, and it's an opportunity for us to meet the people doing the similar research in the same topic, in the same domain, and it's a wonderful time.
We always try to make newcomers as comfortable as they can be, and I can say or recognize on that the importance of the permanent staff, which set the tradition for that kind of welcoming for newcomers.
Saint-Paul-Supélec is an excellent engineering school in France, one of the best ones, and the LGE is a very good lab, a very good environment to grow as a researcher and as a person. So I would definitely suggest to join us.